Hello, friends. This video is hopefully going to be shorter than the previous one. In the previous video, I explained how does networking work in general and OSI model. This time, I'm going to walk you through quite a few basic commands which will help you to test the connection which doesn't work. And the next video, which I plan to do yet, is going to help with intermittent errors. So right now we're not going to look into tracing, we'll look into testing why a specific connection doesn't work at all. And as an example, I will show you inability to connect through remote desktop. And as a bonus, I'll try to explain a bit more about the router's activity, but that will follow up. So let's get on with it. We are starting with a quick look at what we are going to test. If there are any unknown words here or terminology, you can look up most of what I'm saying in the previous video about OSI model. So we are going to have two computers, and the connection will be done, well, the attempted connection, which will fail, will be done through remote desktop. Remote desktop connection is a default application which comes with every Windows, which allows you to connect from one computer to another. One thing to say, you cannot connect to Home Edition. It will not work because the Home Edition doesn't have the remote desktop running on the target side. It can only be used as a client. So in order to understand this concept better, we need to understand that whenever we connect, we don't connect from nothing to nothing. We have a remote desktop connection RDP client on one computer and RDP server, a remote desktop server, on the target computer. So the server component exists only for server applications. So you need to have Windows 10 Pro or Windows 2012 or something like that. Basically the server edition or Pro edition. So you need to have server features. And this connection is of course going through your cables through your network. In our test, it will be going through LAN. So it will go to the switch and then it will go to target computer. But theoretically, instead of the switch, there could be a router with a few unknown devices in between. So in our case, it's a simple setup, but it could be more complicated. So whenever connection happens, it uses specific protocol. So RDP protocol goes to the port, TCP port actually, 3389. And it starts with a random dynamic port. So because we don't have a specific setup which requires remote desktop client to start from specific port, it will always use so-called dynamic ports in Windows. So in our case, the connection should be successful on this port, otherwise it will not work. And of course, in order to connect to this computer in the first place, we'll have to use either IP address, which looks like 192.168.0 something, for example, 5, right? Or we can use the name or host name. In the previous video, we didn't talk about host names, but in any domain, so in any organization, in specific network segment, computers can have names. When you give computer a name, it makes it much easier to access this server, because now, regardless of which IP address it has, you can simply refer to it by name, which is much easier to remember than 8 different sets of numbers. And as a result, you can actually give this name to other people, catalog it, and easier access the computer from other servers in the group. And right now I'm talking about domain name because there is such thing as domain. It calls for a different separate video, but generally it means that there's a segment of network which is controlled by a single organization. And in this segment of network, there are services which support creation of users, computers, roles, assignments, permissions. And one of the services is called DNS, domain name service, which allows to map IP address to the name somehow. So I'm going to show you quickly how it's done and why is it important. In the computer, which acts as your DNS server, which you can find if you simply go to your network connection and then you click adapter options. Here in the properties, you should be able to see the DNS name, physical address. So this is what you would get using ipconfig/all command. I don't see DNS name here, but it should be somewhere maybe in the properties of IPv4. And here, yes. So if you go to advanced settings, here you'll find preferred DNS server. In this case, it looks like 127.0.0.1, and 127.0.0.1 is a service IP, which means computer itself. So quite a few IP addresses do not work like normal IP addresses. They actually carry a specific meaning, and they cannot give them to other computers. So 127.0.0.1 is the local computer itself. So in this case, this is the main controller. If I would go to a different computer like this one, let me log in with a user here. Here you would see that it should also have network connection with DNS settings. If you go to networking, so I'm clicking on the icon in the bottom right and on the network itself, then change adapter options. And here by double clicking and going to properties and IPv4, here we don't have this option. It's taken automatically from the network because this computer is the main controller itself, and other computers in this domain, in this network, will use that computer. So if you want to see what is your DNS server right now, I'm pretty sure it can also be done through command line using ipconfig/o. So this is a go-to command if you want to find information about your network settings. So here, DNS server, as you can see, it has a different IP address, 172.168.0.1. And this is actually IP address of the server here. We can find it by running ipconfig/o and checking IP address. And here you can see 172.168.0.1. So this is a server which has this IP address, which is used by other servers as DNS server. And it means that they connect to this server to find which name has which IP address. And generally, there are two ways to set up IP address. As you can see, in this case, it's static. I have typed it manually. But it could be obtained automatically using a different service, DHCP. And in that case, the DNS server would remember every time the computer connects which IP it has. So next time somebody would try to go to the computer by name, they would go first to the DNS server, ask what is IP, and then go to that IP. And as you can imagine, if this setting is wrong, everything could break. It wouldn't work properly. So if we return back to the picture, here we actually have a bit of different network name. I'm going to adjust it properly. Here we have 172.168.0.1, and the other computer, which is Exchange server, let's take a look at it. It's 172.168.0.2. Okay, so let's correct to make sure that we have proper numbers here on my demonstration picture. Okay, so right now these IP addresses are typed by user. So I manually assigned them for my servers. So they're called static. If the computer wouldn't have this typed, it means it would get it from another server which is called DHCP. This DHCP server is actually a role which is commonly installed on the same server as DNS if you have a small environment. But if you have a big environment, you could have many computers with this DHCP role. The way it works is the following way. On this computer here, you can type in the start DHCP, and you see that it points you to administrative tools. These tools allow you to open a specific server manager, and the server manager is where the magic happens, because server manager is a global tool to administer your server. So for example, if I'm going on the local server, you will be able to see that there are specific services here. As soon as it boots, let me find them. Local server. There should be a feature. I'm looking on the wrong server. I need to check it on DC1. My bad. So here on the local server, you'll see that there is DHCP and DNS, different menus, which I do not have on another computer in the server manager, because these features are not installed on the server, which I have as Exchange server, but they are present on the domain controller server. So here you can actually configure DHCP, and if you're curious how, look up my previous video about the stream where I set up domain controller, and you'll see the settings both for DNS and for DHCP. Right now, I just want you to be aware that these services exist, and DHCP gives out IP addresses and and DNS gives out names. Okay, so why is it important? Most of the time your users will be accessing other computers by name. And if DNS points you to the wrong IP address, the connection will go somewhere else or will not work at all. So very briefly, the way you do check DNS, you need to check two things. There is a type record. So in DNS you have a record and you have PTR record. And these are the most important for connection by names. A says that this IP address should be given to you if somebody calls the name server. And PTR, or reverse DNS, says that if somebody checks the IP address, you'll be given the name. So basically you either get IP from name or you get name from IP. And these are two types of records which exist. PTR is less important because not every time you will be checking which name do you have based on the IP, but you will always check what IP does it have based on the server name. So A is the most important type of record. And A is a record for IPv4. If you ever see AAAA record for A, this is for IPv6. But right now we are focusing on a simple environment with IPv4. All right. So today, if the connection doesn't work, we are going to check that DNS works properly. Besides DNS itself, we also need to verify that the IP address is accessible or available. So we need to check the connection to IP. And this can be done by sending ICMP packets. ICMP is a packet, a specific protocol, which checks if IP is available and comes back. And it gives you information of how much time did it take. So in order to test ICMP, we'll be using the command called ping. You must have seen it somewhere. Ping IP address you get to see if it's responding or not. One thing to keep in mind, if the ping doesn't go through, it doesn't mean that the connection is impossible, because the connection could be working on specific port, like in our case 338.1.8.9, but ICMP could be blocked by a firewall. So if the ICMP does not work, it could be an indication that there's a problem with connection, but it doesn't necessarily mean that the connection doesn't work at all. It could be not a problem that you are troubleshooting. Keep it in mind. Also, of course, when you're pinging the server, before you ping the server, you need to check that it actually has a proper IP, which we'll check by ipconfig command. So ipconfig will be important for us. So it's ipconfig first, and then ping. ipconfig will check on both servers that the IP is correct. They may be from different networks, and if the ping doesn't go through, it could be a bit more complicated. You may have routers which do not route you properly. So another command to check the connectivity that goes through is tracert. Tracert. It means trace route, and it will try to go through multiple hops and tell you how does the packet go and where does it stop. So these two commands will test the most basic connectivity. So today, to check the first thing, you would verify that DNS works. You would test that ping and tracert works. And that would be the first test itself to verify that the IP level connection on the network level may work. But because we are connecting to a specific port, 3389, the problem could be that the specific port is not accessible, blocked, or taken by something else. So the third thing we'll check would be connection to the port, so TCP connection to port, which can be done by a number of tools. You could use telnet, you could use port query, port QRY, or you could use test-netconection. And test-netconection is a PowerShell command which is available in any Windows server. And besides that, you would want to try to check with the netstat on the server to verify if there is even anything on this port 3389. Maybe there is nothing there. So whenever you connect, as I said, we go from client to server, and if the server is not up, the connection will be impossible. So all of these tests could be in vain if we do not check first that we are connecting to something properly. So I would say in my practical life, I would test with netstat first, check that whatever I'm connecting to, is it alive? Because if the netstat doesn't show anything useful on the port running, all the other checks make no sense if you try to troubleshoot connectivity to that port. If nothing works at all, like no programs, nothing, then the rest of the checks make sense. But it would be a very useful step first to understand what's failing, especially if your application has logs, or if you have a knowledge of what kind of connection it is, TCP, UDP, which port, and then go through wider set of terms. So let's actually take a look at this. What's happening is the following. We have two computers that I mentioned, and I'm going to connect to the second computer by name. I'm going to run the command mstsc, which brings up remote desktop. It is the same command you can run as simply typing remote desktop connection in the search bar, in the start menu. And here I'm going to specify the target server name, tchu-ex01. So this is a remote desktop connection, which needs to connect on port 3389 on the other server. So at first, let's say I'm working. So I'm trying to do that, and I see that for some reason it's stuck. These two computers are very close, so they're supposed to connect fast. It doesn't work. So while it's trying, the first thing I do, I'm opening up the PowerShell on the second server, and in the PowerShell, I'm going to check that my port is actually in use. PowerShell. Here, I can run the command netstat, but the command itself is going to give you a bunch of information about ports without much of a useful info. You do not know what's happening here. So what you do want to do, you would want to try netstat minus bona. And these four letters, they're extra filters, extra flags, which enable extra information for netstat. So right now, we are doing the command netstat minus bona. You can change the order of these letters, it doesn't matter. So if you run it like this, you can, well, at first it doesn't let me do it because my PowerShell is running as a simple user. So I have to run it as administrator. I'm going to right click and run it as admin. And this way, now if I type netstat minus bona, besides the IP and information, it also gives me the service name in square brackets under the port. Now, yeah, this is very important to recognize that the first comes the port and then the name of the service. Because normally you could think that it's name of the service and port then, and then you'd be misreading the lines. So whatever is the port, the service will be below it. And right now it's good, but I am curious about port 3389, which I know is used by remote desktop, which fails to connect. As you see, it gives me a big fat error. And from this menu, it's very hard to see it. So what I could do some kind of grep or whatever, but I'm just going to use triangle bracket and then C temp or the C output txt. So this triangle bracket means that the output that would go to the console should go to the file instead, or to another location. So now I'm sending everything that would be normally on the screen into this file C output txt. And now on the C drive in this file, I can simply find Ctrl+F 3389, which tells me that there is a terminal service running. So term service is the remote desktop service. So it is actually up and it is listening. So the listening status means that this port is ready to accept connection. In this case, I shouldn't worry that I forgot to enable remote desktop on this computer. It's actually listening on the port. So in our case, so far, we have gone and tested netstat minus bona into file C out txt, and we saw that port 3389 is listening. And it's listening by term service. For example, if you were troubleshooting some other software and you noticed that it is listening but the name is wrong, it could be that some other software took your software's port. For example, service printer spooler, a specific service which jumps around, likes to take any random port available. So this spooler service could take a port from your application. Now that we know this, if we make a picture again, we know that here port 3389 is okay. So the problem is elsewhere. Either the connection doesn't go through or something else is afoot. And we know that we are connected by the name DCHU-EX01. So let's check if the IP address is all right based on this name, if DNS works correctly. So if you do have access to DNS server, you could simply go and check the settings here in the server manager. You click on DNS, Tools, DNS. And now there are two sections where you configure DNS. It could be forward lookup zone, where you have your domain, and this is where you match the name to the IP, and this is the A type record, as I said. And you have reverse DNS, where you match IP to name, and here you see the IP is matched to name instead, and this is PTR or reverse DNS record. So in this case, I can see that if I go to 02 in my network, it's supposed to point to the server DHCU-EX01, and if I go to the forward zone to this name, it should go back to 02 IP address. So this seems to match correctly. Just to verify, in the PowerShell, I'm going to type ipconfig, and it will show me, yes, this is the correct IP. And also I'm going to type hostname, and yes, this is correct name. And finally, from the server I'm connecting from, I'm going to go to the PowerShell as well, and I'm going to type nslookup DCHU-EX01. And this way I can see that it is pointing to the correct IP address. And I can also nslookup the IP address and check if the reverse DNS works. 172.168.0.2. And now it tells me the correct name. So both name and IP are set up correctly, which means that if we wanted to check DNS, on the next step here, we would use nslookup command and then use either IP address or DNS name. And we would check IP name, IP address with ipconfig, and we would check DNS name with hostname commands on the target server. So the configuration is correct. Now let's see if the connection actually works. And this is the third step, which I mentioned before, where we want to check this ICMP connection. So the next command I'm going to run is going to be ping command. The ping command accepts the following format: ping plus IP address. So this is like the most basic network testing command. And again, this would send ICMP packet, not exactly TCP connection that we are doing with remote desktop. And it's just checking if it goes through or not, and ICMP could be theoretically blocked. So it's not necessarily the best test, but it would be useful. So let's do it. Here I'm going to ping my server DCHU-EX01, or I could use IP address. And you can see that you get a reply, and it tells you how much time passes, less than 1 millisecond. Ping works, which means that in our case, the connection through the cable reaches the target network card on the IP address and comes back on the network layer. So the problem is somewhere on the TCP layer, most likely. We cannot reach the port, even though it's listening. So it is interesting. So the next step, let me put numbers next to them, 1, 2, 3, 4. On the next step, I would actually check if this port is reachable, because we know it's listening, but we don't know if it's reachable or not. So here we could use a bunch of tools, telnet, port query, maybe some kind of other tools, but I'm going to use test-netconection, and the flags are minus Computername, and here we put name, and then minus port, and here we put 3389. So name is my DCHU EX01. So this test will verify the connectivity through TCP on specific port. Let's do that. So test-netconection minus Computername DCHU EX01. It should work fine now because we verified the DNS works. And minus port, and the port is 3389. So this is supposed to test and show us the result. So far it is waiting for response, and I don't expect this to work because RDP doesn't. And it's not going to work, and while I'm waiting, I'm going to explain why. If the port doesn't work while ICMP works, most likely the port you see it says TCP test connection succeeded false. It is blocked by something. It could be some kind of intrusion prevention system or firewall. It could be on the router, but in our case, we know it goes there in one hop, so most likely it's a target computer. So the first thing you want to check here is to go to the target computer, to the network settings, and check the firewall settings. Windows Firewall, in the bottom, you should have, at first you check that it's on. You could turn it off, and you could go to the advanced settings in the bottom, which opens up all the different configuration settings you can create. And I'm counting on inbound rule being wrong. So here you have a bunch of rules which are predefined by Windows, and some administrators could make more. And I'm interested to sort by local port. So I need to check port 3389. Let me see, 1, 2, 3, 3389. This rule is remote desktop rule. And this says that rule is supposed to be allowed. Let me check, apply here. This is interesting. What was wrong? Remote desktop 3389. Let me check it again. 3389. I think I checked UDP rule. Yeah, make sure to pay attention to the transport mode. So UDP is allowed, but TCP above, I just noticed, it has this red icon. So the TCP is blocked. So what happens if I allow the TCP connection here? I expect it's going to work now. So let me try this again, and it suddenly works. And if I try to use remote desktop again, it gives me ability to log in. And now if I type it, if I type the login password, now we are connecting, securing remote connection. So in this case, we did the following steps. It's going to connect shortly. I'm going to show it. I'm just going to repeat it. So at first, we verified with netstat command on the target server that the service we are connecting to is listening. It is very important to understand if the connection fails, what kind of connection is failing. Is it a general ICMP or is it a specific TCP connection? And if it is a specific TCP connection, you will want to know which port you can connect to. If your software that you're troubleshooting has proper logs, you will have an error message about specific port. If it is a common software like remote desktop, you can quickly look up remote desktop ports. Right now, if I wouldn't know what to do, I would go to Google Chrome and type here remote desktop port section on the top. And you'll see immediately the number of the port, so you can easily check it. If it's some kind of custom software and you are working in support, you might have to ask a QA or tier 2 or higher department which port is in use, because some of your colleagues know it for sure. Or maybe you have documentation which tells you which ports are in use. In any case, this is a mandatory check to see if what you are connecting to is actually running there. And then if it is running, you can start checking the basic things, such as if you're connecting by name, if DNS is working, and if you're connecting by IP, you can skip second step and test the ping. If the ping works, you would want to do test connection on the port to verify if it works or not. If the ping doesn't work, you still should try to test the port, because there is a chance the ping ICMP is disabled, but test-net connection is not. And finally, like what would be the worst case scenario, but you need to be aware that it can exist. Between two computers, let me use a different color so it's not red. I want to show you the problem with red. So you have two computers, and let's say cable is okay, and IP addresses are okay, but ICMP is blocked. So ping doesn't work. and your port 3389 is blocked. So a test to TCP using the tool doesn't work. If ping and test doesn't work, it doesn't always mean that connection is bad. It could mean just a very strict firewall. So you will still try to do trace RT first, trace RT, to see which devices are on the way. Like, let me give you an example from my computer. If I run trace RT here to google.com, you'll see every hop in between. And you can see it tells me the time it takes. And at some point it may stop. And that would be likely the device which is like a firewall or specific router which blocks your connectivity. It doesn't mean that it stops it completely, but it can take a while to go through. So you could ask the networking team to go through these devices that you see here and check which one may have your port blocked or ICMP blocked. And eventually it's just a matter of understanding that. If you want to get a lot more information, you would have to use a tool like Wireshark. Because if you send TCP and it's blocked, you'll get a TCP reset packet back. But you wouldn't normally see it through common tools like ping or test-net-connection. You would have to actually capture and trace the packets. And that is something that my future video will be about. But as a bonus, I wanted to quickly explain how routers work on IP level, so you would have a bit of a better understanding. So there is a common misconception how router works in general, because people definitely know about NAT most of the time. I'll tell you what it is. But not everybody pays attention to PAT. So NAT is network address translation, and PAT is port address translation. What does it mean? Let's say you have a router device, and you have two computers connected to it. These two computers have their unique IP addresses, let's say 172.168.0.5 and 172.168.0.6. But when the router goes to the internet, it goes through some kind of internet service provider, and it only has one IP address. For example, 10, I don't know, like 515, something stupid like that. But usually it's a public IP address, so it starts with a specific number like 10 or whatever. And yeah, generally there are, let's say, agreements how the IP addresses should work. Because you could use IP address which looks like 10 something internally, but we agree that there is a specific range reserved for private IPv. Private means that it's behind your router. So here you have a private segment. And there are a bunch of IPs which are called public, which are used for the internet, public IP addresses. So when public IP addresses range is exhausted, that's when we'll start thinking about IPv6. But right now, it works like this. So now I'm going to ask you a question, and I'm going to answer it myself, but I will let you think for a second. Let's say we are going to YouTube to watch a video, YouTube. And on the first computer, we are going to connect and get a dog video. So here we have dogs. And on the second computer, we are going to connect and get a video with cats. So this is what we do most of the time when we use multiple computers. The question is, how does it work? Because imagine here we get a package coming, and this is a dog package for the first computer. Well, it's a dog video. And then we have a packet coming, and this is a cat packet with for the second. As we discussed before, all network connections go from source to target. And in your case, you use your public IP to talk to YouTube. YouTube doesn't know your internal IP addresses. There are millions or hundreds of thousands of people using the same IP addresses internally. Your public IP is unique, so both packets would come to the same public IP. So this dog IP packet will come to 10, 10, 5, 15, and the cat one will also come to 10, 10, 5, 15. So how will the router understand which one is which if they both come to the same IP address? So normally, whatever happens, when you go outside, you are routed to Google, and your source IP becomes public IP. And this change is done through NAT, Network Address Translation. What does it actually mean? Let me draw it a bit. So let's say you have computer 1, you have router, and you have somewhere another router because it's your internet service provider router. Or usually it might be internet switch somewhere. Okay. So here you have your public IP outside 10 something something, and here you have private IP 172.168.0.5. So when the packet is going, it's going to have source 172.168.0.5, and target is your default gateway setting, which is usually like 0.1 at the end or 1 at the end of your IP address, but it could be whatever it's set up as your gateway. You can check it in your IP config output. So the target will be not this, because then it would end up, the target would be Google, or in our case, it's going to be youtube.com, which got resolved in some kind of IP address. And this is why you go to your gateway in order to get out. You know, it's not inside of your network. And besides source and target IP, you would have the source and target MAC. And MAC address always changes on hops. So here you have computer 1 MAC, and here you have router MAC 1, which you have internally. And on another segment, it will go from router MAC to switch MAC. So these MACs will keep changing. You cannot use MAC address to keep the information about source and target of the destination. It's not going to work. Besides that, you need to somehow shield your IP, because it's your internal IP, it's your private IP. So once this packet passes the router as a target IP, it will still use youtube.com, but the source IP gets changed into 10, and whatever IP your router has as a public IP. And now this packet will go through the whole provider network and to the Google, and it will come back as, so this is data going out from your computer, and this is for the dogs, right? So this is a dog packet. And then it comes back. And when it comes back, the source and the target switch. So now source is youtube.com, and target is your public IP of the router. So here is where we get this problem I explained. This packet comes in, it left fine, but it came back, and your IP address that you knew about before, the one which you have for the computer, is not inside of this packet. So you cannot really tell if it's for your computer or for your friend with cat videos. Well, in this situation, we have to rely on the transport layer protocol, because whenever a packet left, it left from some random TCP port. For example, 30,154. And besides source IP, this packet had source port 30,154. And it comes back to the same port, 30,154. And this, when you connect outside, this is why you need to remember the outgoing port, not only target port. And the connection comes back on the same port, which means that you keep the same connection to your original computer. And now you can match the port to IP address 172.168.0.5, which it left from initially. And this is where port address translation comes in. There's also a setting, you must have heard about it, it's called port forwarding, when you can forcibly take, let's say, port 80 and map it to port 80 on specific internal IP. And this will allow you to actually configure the specific port to connect a specific port on your computer application. And this way you don't have to set up extra rules, and you can use your public IP for services which do not work well with port address translation. For example, it is frequently encountered in a computer game where you want to set up a server and you want your friends to connect to your server. This server will use your public IP because you are behind the router. And if you port forward to internal IP, everybody can connect to public IP and port of the game, and that will redirect them into your specific computer. You can also set up a bunch of different ports to different internal IPs, and it's a bit of an interesting discussion how to set up the router properly, but overall, I just want you to remember two things. When you connect through the router, and the router allows multiple connection, there is no magic involved. When you go through multiple internal IP addresses, it uses network address translation, and your IP addresses all get replaced by public IP. So everything that leaves here to the internet will have IP4, which is your external public IP. But because you need to track where it came from, this is where PAT will be used, and there will be port 1, port 2, port 3, which are matched to internal IPs. And when the traffic comes back, it will come to the same port on transport layer and can be redirected without any issues. Hopefully, this was a useful explanation. It was addition to what I said before, and it can be practically applied in a few scenarios. For example, if you are troubleshooting a multi-stage connection from multiple computers or routers, and you are actually sniffing traffic, you may want to check what is an outgoing port for your connection here, and set up a filter to only listen on this port. This way, your traffic you sniff is going to be limited, because otherwise you'll have a lot of extra noise from other connections. So understanding how this works helps at first to set it up correctly, because if you, let's say, disable specific features of PAT, you can make it impossible to use the router properly. And it helps to set up sniffing or network capture, which only filters what you want. You will also use this knowledge if you want to set up port forwarding, but otherwise, this is a bit advanced in comparison to what I said initially about a few basic commands. So if you stuck around, I'm very grateful to you. If not, it's not a problem, but you will need to understand what I explained in the router section if I'm going to get into more details when I talk about Wireshark and network capture software. It is pretty late here, so I'm going to wrap up. Hopefully, these 5 commands, netstat, nslookup, ping, tracert, which I didn't write here, but it's going to be useful. Let me write it down. Hopefully, these 5 commands will fix most of the problems you have, or at least you'll find where they are, so you could tell the responsible person to correct the equipment and configuration. This is not very helpful if you're troubleshooting connections which generally work but fail from time to time, because you'll come and test that it will work, and then at 2 AM it will fail. In that case, you'll have to set up network capture software, and that's the topic for the next video. Thank you and goodbye.